Okay, everybody does, but the technical here. Technically mine. Second take your own.
Yes. And so, I get rid of the.
Alright, kids,
Hey, can I have a
everybody
break?
listen up, please. You just took your test over ionic bonding, ionic names and formulas. Okay, this is a second type of bonding, and it's called covalent bonding. In ionic bonding, atoms transfer electrons from one atom to another. The number of ionic compounds is small compared Am I running off the paper just about? Compared to the total number of known compounds. The number of ionic compounds is small compared to the total number of known compounds. The type of bonding in these other compounds is called covalent. The prefix co means to share. Valent is from the word valence, I should have remembered that because I printed it off tomorrow and the next day because that's when I had kids that were going to be affected in missing class, but I didn't. Valent is from the word valence, indicating valence electrons. So in this type of bonding, they're going to do what with their valence electrons? Share them. Okay. The shared electrons are considered to be part of the complete outer energy level of both atoms. The majority of covalent bonds formed between nonmetallic elements. Which is basically nonmetals. Nonmetallic means nonmetals. Okay, if you remember back in ionic was a metal plus a nonmetal, or polyatomic, yes. Cation hooked to an anion. Now what's the difference? These are going to be two nonmetals. For binary, it'll be two nonmetals from the top side of the zigzag. Does that make sense? Two nonmetals from the top side of the zigzag. Okay? Definition, molecule. Formed when two or more nonmetal atoms bond covalently Another definition is diatomic molecules.
Could you move it up?
Yes. What's prefix di mean? Two. Yeah, you're going to learn prefixes in covalent bonds. Mono, di, tri, tetra, what's five? Penta, and so on. That's how the naming system on these kind of covalent bonds, naming them works. Okay, diatomic, di means two atoms. Okay, now diatomic molecules, they are atoms of the same element hooked together in a covalent bond. You all right? Now then, these are only very specific ones. Okay? Not all covalent compounds are called diatomic molecules. They're only very specific ones. They are H2, N2, O2, F2, Cl2, Br2, and I2. Now these are very important because you're going to see when we start chemical reactions that anytime you write any of these elements by themselves, not in a bond with another element, this is how it will always be represented. Always. You'll never just write H, it'll always be H2, N2, O2, F2. So if it says hydrogen in your chemical equation, you're going to write down H2, and so on, okay? Diatomic molecules occur in nature so this is how you find those elements in nature. Always hooked together, two hydrogens, okay, two nitrogens. Because the molecules formed are more stable than the individual atom. Are more stable So for anything, any element on the periodic table, the majority of them are found in compounds, kids, due to increased stability. And so it also applies to the elemental diatomics also. That's why they hook together in a pair. Is everybody done? I'm going to go to a new page. Okay, each fluorine has 7 valence electrons. Why is that? Where does fluorine live? Yes. Each fluorine has 7 valence electrons, and each need 1 more to form an octet. What is an octet? 8. Everybody wants how many valence electrons in their outer energy level? 8, because that's what the who have?
Noble gases.
Noble gases, except for who? Not hydrogen, it's not a noble gas. Helium, and helium has 2, okay? All right. So we're going to work with some Lewis structures here. So this F is represented by how many valence electrons? 7. Okay. Another F is represented by how many valence? Now I'm going to specifically leave my blank spot in the middle. Okay. All right, so that means I'm going to start up here and go around this way. Now then, what can you see from this? If they were going to hook up Can you see that them moving closer together? And can you see that this, if they move closer together, it will end up looking like, what do you think? You see that? You see that? Now, if you cover up this one, how many valence electrons does it have? 8. If you cover up this one, how many valence electrons does it have? 8. Right here is the shared pair. That's the covalent bond. That is the covalent bond. As the two atoms move closer to each other, the attraction of both nuclei for the other atom's electron increases until the maximum attraction is achieved. Okay, so we're going to look at this again. F2, okay? So F2 looks like what we did up on the top right. So you've got this F, 1, 2, 3, 4, 5, 6, and then right here we'll put the 7, 8, put the other F here. Whoa! Don't ask me why I did that. 1, 2, 3, 4, 5, 6, and there's the 7, 8. Yes? Okay. Now, we're going to kind of use a Venn diagram here. This one has 8, and this one has 8. And inside the circle right here shows your shared pair. Does everybody see that? So this is showing that there's one shared pair that makes each fluorine have 8 in their outer energy level. Okay? Now I want to show you another way that you can see this. You can see both F's with the shared pair demonstrated as a straight line between them, and then we'll put the dots on the outside. So that's another way that a shared pair is indicated, a straight line. Okay? So what we have over here, the straight line, indicates a shared pair. Now then, how many unshared pair does each F have? How many unshared pair does this F have? 3. Remember, a pair is how many? 2. So you're counting a pair. There's 1, 2, 3. Everybody see that? 3 unshared pair. So 3 unshared pair for each F. Okay? Alright, now we're going to look at hydrogen. How many valence electrons does hydrogen bring to the party? 1. Okay. So we've got hydrogen with 1 valence electron, basically, plus hydrogen with 1 valence electron. Now can you see where they're going to hook up in the middle? Okay. So that goes to hydrogen, and it's 1. This hydrogen, and it's 1. Okay? Hydrogen is like helium. Its outer shell is filled with how many? 2. Okay? So do your Venn diagram. There's 2 for hydrogen and 2 for this hydrogen. Okay? So this right here basically is H2's helium configuration. No, off the paper. Okay? Because remember, everybody is trying to get a noble gas configuration in their outermost energy level. Yes? Okay. Any questions so far? Okay. I'm going to go to another paper, kind of starting with. Single covalent bonds is the heading. Definition, single covalent bond. One shared pair. Whoa. Not an I. Of electrons. Okay, so we're going to look at each group on the right side over there. Group 7, 6, 5, and 4. So in group 7, elements have 7 valence electrons. To attain an octet, one more electron is necessary. So an example, we're going to use Br this time. Is Br going to look exactly like F? Are they in the same group? Yes, it will look exactly like F. So we've got this Br bringing 7 electrons to the party. And I'm going to put my other Br right next to it and do my 7 from this one. And finish it off with the shared pair in the middle. Do your Venn diagram. This Br has 8. And this Br has 8. So guess what that makes? Br who? Br2. Okay, so now let's look at group 6 elements. Let me put the A on these so everybody knows that I'm talking about the Roman numerals. 6A elements. Okay, group 6 has how many valence electrons, kids? How many do they need to make 8? 2. Okay, so group 6 elements share 2 electrons to form 2 covalent bonds. Whoa, I don't want that. To form 2, and I'm going to put single covalent bonds. Example is going to be water. Okay. All right. Your most electronegative element will always take center stage. So we're going to put oxygen here. There's my O. Okay. Now then, I'm going to kind of offset this, and I'm going to do it for a reason. There's 1, 2, 3, 4, and then 5, 6. Okay? Did I give my O 6 valence electrons? Okay. Now then, how many electrons does hydrogen bring to the party? No, each hydrogen. 1. Okay. So, guess what? Here's my hydrogen right here. And where's its 1 going?
Right there.
Here's my other hydrogen down here. And where is its 1 going? Okay. Now, cover up the H. Do you count 8 electrons around oxygen?
Yes.
Okay. Cover up this part. Do you count 2 for each hydrogen?
Yes.
All right. Now we're going to do our Venn diagram. So, first one is around for oxygen. Okay, showing that it has 8, and each hydrogen has 2. Okay. Now, this is 2 shared pair. 2 shared single covalent bonds. This is a single covalent bond, and this is a single covalent bond. And you can also see me call it 2 shared pair. 1, 2. Now then, I'm going to draw the actual shape of water, and that's kind of why I did it here. So here's your oxygen again, and you see how I put these unshared pair up here at the top like this? Okay. And then we're going to hook hydrogen with a straight line. What does the straight line tell you about it? It's a shared pair. Okay. Now what we have here is 2 unshared pair at the top. And this is going to come into play later. 1, 2. Okay? And 2 shared pair down at the bottom. One, 2. Questions? Okay, so group 5A. Five and what make 8? So how many covalent bonds are they going to form? 3. Group 5A elements form 3 covalent bonds. Example is ammonia. The formula is NH3. Okay, so we're going to take in, put it in the center. Hydrogen will never take center stage. What did I just say? Okay, you're always looking to put the element closest to the right side of the periodic table in the center. Okay, so nitrogen has how many valence electrons, kids? 5. Now I'm going to put my 1, 2, 3, 4, and double up at the top on 5. Okay? Now can you see where your 3 hydrogens are going? Okay, so we'll put one here and a dot. We'll put one here and another dot. And we'll put one here and another dot. Questions? Okay. Draw your Venn diagrams. How many's around nitrogen now? 8. Okay, and each hydrogen is happy with, each hydrogen has 2, which is the helium electron configuration, and nitrogen has 3 shared pairs. Okay? So we've got 3 shared pair, and what?
1 unshared.
Yes. And again, these unshared pairs are going to come into play later when we talk about polar and nonpolar. It's not pearl. Okay, last page. Whoa, is it 57? Let me do group 4A. I can get that done by. How many shared pairs group 4 going to have? Group 4A will form 4 covalent bonds. Example, methane, CH4. Okay, look at carbon. It's in group 4. It has how many valence electrons?
4.
Okay, so the C goes in the middle. Put your 4 dots and attach your what? Your 4 hydrogens. Where are they going? At all 4 what? Mm-hmm. Each one bringing how many dots? 1. Now your carbon has how many? 8. Venn diagram it. Okay, and then do your single shared out here with each hydrogen.
4 shared, 1 unshared.
No, they're all shared.
Oh, wait.
There's 4 shared pair.
Oh, yeah.
Okay?
Hey, I'll bring it back to you. Bring it back to you.